Namaste children, welcome to today's maths class. And in the last class we were discussing compound interest from the chapter comparing quantities. That is exercise number 8.3. And now we will continue that same topic from exercise number 8.3, question number 6. Arif took a loan of rupees 80,000 from a bank. Arif, a person, he took a loan from a bank. How much he took the loan? 80,000 rupees. If the rate of interest is 10% per annum, rate of interest is how much? It is 10% per annum. Find the difference in the amounts. Find the difference in the amounts means how much amount he will pay after a certain period. What is the period it is? He would be paying after 1 by 2 years in the if the interest is. So here the time period is 1 by 2 years means 1.5 year is the time period. After 1.5 year, how much amount he will pay if the interest is calculated, compounded annually. If the amount, if the interest is compound interest is calculated year wise, that is annually. Similarly, if the interest is calculated, that is compounded half yearly. Here two cases are there. Compounded annually, compounded it is year, half yearly. How much he will be? Find the difference in the amounts he will be paying after 1 by 2 years. It means that what we have to calculate? Find the amount he would be paying if the compound interest is calculated annually and also compounded half yearly. For both the cases we have to find, we will get the two amounts. One it is compounded annually, the other one is compounded half yearly. Then subtract those two, we will get the difference in the amounts. Difference in the amounts. Now, what is the principle here? It is P is equals to rupees 80,000 rupees and time is equals to T. It is 1 by 2 years. 1 by 2 years and then rate of interest R is equals to 10%. Rate of interest R is equals to 10%. Now the first one, compounded annually. Compounded annually. Compounded annually. What does it mean? Compounded annually means the interest is calculated every 1 year. Every 1 year. But here we have 1 year and half year is there, is 6 months is there. How to do this kind of sums? Find the simple interest rate. Find the compound interest for 1 year. Find the compound interest for 1 year. Next, we get the amount what we get for 1 year. That amount will be treating as the principal for next half year. For next half year, and find the simple interest for that half year. So here, find the compound interest for 1 year. That is, find the amount for 1 year. That amount will be treated as the principal for the next half year. For the next half year, you find the simple interest, and that if you add to the amount, the principal which we got, which we have taken to find the simple interest, then we get the total amount he would have to pay after 1.5 year. So here, n is equals to what? For 1 year we are paying. Then we find the half year, it is 6 months. So treat n is equals to 1. Time period is 1 year. Now what is the formula? It is A is equals to P into 1 plus R by 100 whole to the power of n. Now see here, that is equals to A is equals to P, it is 80,000 into 1 plus R is equals to 10% divided by 100 whole to the power of n is equals to 1 year. Now 10 ones are 10, 10 tens are 100. Now what we get, it is 80,000. Now 1 plus 1 by 10, you get by adding this 1 plus 1 by 10 whole to the power of 1 is this, same we get 1 plus 1 by 10, that is 80,000 into, so take here 1 means this 1 by 1, 1 into 10 it is 10, 10 into 1, 10 plus 1 is equals to 11, we get by simplifying this, then we get 11 by 10, 11 by 10, now cancel these two. 0 and 0 will be cancelled. Now multiply with 11. 11 8s are 88. 11 8s are 88 and keep 3 zeros. So what is the amount after 1 year he has to pay? 88,000 rupees has to pay. But we have to find the amount for 1.5 year. 1.5 year. So we found this amount for 1 year using the compound interest formula. Next for half year, find the interest using the simple interest. Now here, time t is equals to find for simple interest half year, that is 6 months. So rate of interest R is equals to same rate of interest. It is 10% we are finding, and then principal it is. Now here what is the principal? The amount which we got here, this amount will be treated as the principal for to calculate the simple interest for the next 6 months. For the next 6 months. Now simple interest I is equals to PTR by 100. I is equals to PTR by 100. Now substitute what we get it is T is equals to principal 88,000 into time T is equals to what? 1.5 year into rate of interest R is equals to 10 divided by 100. Divided by 100. Now you see here 2 zeros and 2 zeros are cancelled. 2 ones are 2, 2 fours are 8, 2 fours are 8, 2 zeros are 0. Now what it is? 440 into 1 into 10. Multiply with the 10. 1 into 10 is 10. Therefore you get interest is equals to how much it is? 4,400 rupees is the interest for that 6 months. For that 6 months. Now what is the total amount he has to pay after 1.5 year? Total amount is equals to, what is the total amount he has to pay? The principal P plus interest, that is simple interest. Principal it is 88,000 plus 4,400. So by adding this what we get? 0 plus 0, 0, 0 plus 0, 0, 0 plus 4, 4, 8 plus 4, 12, 1 plus 8, 9. So how much he has to pay? 92,400 rupees he has to pay after 1 year if the compound interest is calculated annually. So here we have 1.5 year is there. So first you find for first year the amount using the compound interest formula. Then you treat that as the principal for next 6 months, for the next half year, and find the this simple interest. Add that simple interest to the principal which we got from the compound interest formula. Then we get the total amount how much he has to pay after how much? 1.5 year. Next the second one, what it is? Compounded half yearly. Compounded half yearly. Compounded half yearly. Then what is the amount he has to pay after 1.5 year? So here the principal is same. 80,000 rupees is the principal. Time it is 1.5 year. Time is 1.5 year. Therefore N is equals to, for 1 year half year, how many half years are there? Here half yearly means number of half years. How many half years are there in 1.5 year? For 1 year we have 2 half years, and again 1 more half year is there. Therefore total 3 half years are there. So N is equals to 3. What is N here? Number of time periods. Here the compound interest is calculated half yearly, means every 6 months. So here in 1.5 year we have 3 6 months are there. Therefore N is equals to 3, and rate of interest is equals to what it is? 10% per annum. This is 10% per annum. But for 6 years, every 6 years will be half of the rate of interest, which is R by 2, which is equals to 10 by 2, that is 5%. 2 ones are 2 fives are. 5% is the rate of interest for 6 months. Now we know the principal is 80,000 rupees, time N is equals to 3, and rate of interest is equals to 5. Now find the amount. Again amount A is equals to, the formula is A is equals to P into 1 plus R divided by 100 whole to the power of N. So here A is equals to, P is equals to what it is? 80,000 into, then what it is? 1 plus R is equals to 5 divided by 100 whole to the power of N. N is equals to what is here? It is 3. N is equals to 3. Now simplify this. We get 5 ones are 5, 5 twos are 10, 5 zeros are 0. That is 80,000 80,000 into, so 1 plus 1 by 20 whole cube, that is 80,000 into 1 into 20, it is 20, 20 plus 1, it is 21, 21 by 20 whole cube, 21 by 20 whole cube, that is equals to 80,000 into 21 by 20 into 21 by 20 into 21 by 20. So here you have 3 zeros are there, 1, 2, 3. So cancel 3 zeros. So now it is 80. 2 ones are 2, 2 fours are 8, 2 zeros are 0. Again 2 ones are 2, 2 twos are 4, 2 zeros are 0, 20. Again with 2, 2 ones are 2, 2 ones are 2, 2 zeros are 0, that is 10, 10 twos are 20. Now everything is cancelled in the denominator. Now what are the numbers which are left over here is 10 into 21 into 21 into 21. Multiply all those numerators. We will get the total amount, how much he will pay after 1.5 year. If it is calculated per that is half yearly, if it is calculated, how much we will multiply this. Now we will continue the calculations. That is equals to amount A is equals to what we got, 10 into 21 into 21 into 21, multiply. So 10 into 21 it is 210 and it is multiplied with what? 21 into 21, what it is, what will be the answer? It is 441. So multiply with 210 with 441, we will get 1 zeros are 0, 1 ones are 1, 1 twos are 2, 4 zeros are 0, 4 ones are 4, 4 twos are 8. Again with 4, 0, 4 and 8, add all the products, 0, 1, 6, then 12, 9. So how much it is? 92,610 rupees. So A is equals to rupees 92,610 rupees. So this is the amount he has to pay to the bank after 1.5 year. If the interest is calculated half yearly, compound interest is calculated half yearly, and this is the amount he has to pay after 1.5 year to the same bank if the interest is calculated annually, in which case he has to pay more amount. So here half yearly it is 92,610, yearly it is 92,400. So he has to pay more money when in the form of half yearly when the interest is calculated half yearly. How much money? The difference they ask here. Therefore, the difference in the amounts is equals to the difference in the amounts. Difference in the amounts. The difference in the amount is equals to what it is. This is the amount which he has to pay if it is calculated half yearly, and this is the amount he has to pay if the interest is calculated yearly, that is 92,400. Subtract 0, 1, 6 minus 4 it is 2, 9, 2 minus 2 0, 9 minus 8 is 0. So how much it is? Rupees 210 rupees he has to pay. That is the difference in the two amounts when the interest is calculated half yearly and annually. So what we have done here, it is we have to find the amount when the interest is calculated annually, and we have to find the amount when the interest is calculated half yearly. Then subtract both the amounts, we will get the difference amount which he will find. Clear children how to do this kind of sums? Yes. Now we will discuss applications of compound interest formula. Where we use this formula? In addition to that, finding the compound interest. Increase or decrease in population. One application is increase or decrease in population of a city or of a country or of a locality. The growth of bacteria, if the rate of growth is known. If the rate of growth of the bacteria is known, then we can find the growth of the bacteria. Similarly, this is very known to us. The value of an item, if its price increases or decreases in the intermediate years. For example, if you purchase a car, next year if you want to sell that car, the value of that car will decreases. The value of that car is decreased. Similarly, if you have purchased one plot, that plot if you wanted to sell next year, the price is increased. The price is increased. It increases year on year. The price also increases, whereas the vehicles, the price decreases. We use this compound interest formula to find in these situations. So to increase, if there increase for increase in the population or increase in the price, we use the formula as A is equals to P into 1 plus R by 100 whole to the power of n, same it is that is same formula what it is, compound interest. If it is decrease is there in the population or decrease, or it is decrease in the value of an object, an item or a vehicle, then decrease means we will represent with the negative sign. Therefore A is equals to P into 1 minus R by 100 whole to the power of n. Then by substituting the given values in this formulas and on simplification, we will find the required things. So where we use increase or decrease in population, the growth of the bacteria, the rate of growth is known, the value of an item if its price is increased or decreases in the intermediate years. Is it clear, children? The applications, we will discuss one question related to this concept. Now, we will discuss exercise number 8.3, question number 12. A scooter was bought at rupees 42,000. Its value depreciated at the rate of 8% per annum. Find its value after 1 year. Depreciated means decreased. The value of the scooter is decreased by 8% per annum. Find the value of the scooter after 1 year. After 1 year. So we use compound interest formula to find the value of the scooter after 1 year. So from the given question, P is equals to what? It is rupees 42,000. 42,000. Rate of interest R is equals to 8%. Time T is equals to 1 year. That is 1 year is N is equals to 1. It is decreasing per annum, yearly it is decreasing, therefore N is equals to 1. So what is the formula which we use? A is equals to P into 1 minus R by 100 whole to the power of N. Why we are using here 1 minus R by 100? Because the value is depreciated, it is decreasing, therefore minus R by 100 will get it. Now substitute in this. P is equals to 42,000 into 1 minus R is equals to 8 by 100 whole to the power of 1. Simplify this. That is equals to 42,000 into, it is 4 2s are 8, 4 2s are 8, 10 minus 8, 2 bring 0, 20, 4 5s are 20. That is 2 by 25 we got it. That is 42,000, 1 minus 2 divided by 25 will get, here the power is there 1, so we'll get 1 minus 2 divided by 25. Now you simplify this, it is 42,000 into LCM it is 25. So 1 into 25, 25 minus 2, that is equals to 42,000 into 25 minus 2 is equals to 23 divided by 25. Now simplify this. 5 5s are 25, 5 5s are 25 and it is 5 8s are 40, 5 8s are 40, then 42 minus 40, 2 with 0, 20, 5 4s are 20, 5 zeros are 0, 5 zeros are 0. Again it is divisible by 5, 5 1s are 5, 5 1s are 5. So 8 minus 5, 3, bring 4, 34, 5 6 are 30, 4 is there, bring 0, 40, 5 8s are 40 and 5 zeros are 0. Therefore, what we get is 1680 into 23. 1680 into 23. Multiply this 1680 into 23. So multiply this, the product will give you the value of the scooter after 1 year. So 3 zeros are 0, 3 8s are 24, 2 is there, 3 6 are 18 plus 2 20, 3 1s are 3 plus 2 it is 5. With the 2 zeros are 0, 2 8s are 16, 1, 2 6 are 12 plus 1 13, 2 1s are 2 plus 1 it is 3. Now it is 0, 4, 6, 8, 3. How much it is? 38,640 rupees. So how much we get it is? Rupees 38,614. Therefore, the value of the scooter, the value of the scooter after 1 year is equals to rupees 38,614. Rupees 38,614. So like this we will find the depreciated value or the value of the scooter after 1 year when the depreciation rate is given, that is 8% is given. Is it clear, children, how to find this? That is the application of compound interest formula. Yes. Now I hope you understand what we discussed today, that is the applications of compound interest, how to calculate compound interest half yearly, annually and its applications. With this chapter is completed, and what we discussed in this chapter it is, so we have studied simple interest, compound interest, its applications, selling price, cost price, profit, loss percentage, profit percentage, and finding the problems related to the concept purchasing and selling values. Finding the profit when we know the CP and SP. Finding the profit when we know the profit percentage and the CP. Finding the profit percentage when we know the CP and SP. Finding the CP or SP when we know the profit percent or loss percent and the other one. And similarly, we have studied VAT, value added tax, GST related problems, and then we have studied problems related to what it is, percentages, ratios, percentages, their conversions, and all those things we have studied in this chapter, that is market price, discount price. So many topics we discussed in this comparing quantities chapter, and you have to apply this knowledge in your real life situations. So we use this knowledge abundantly in our real life. I hope you will apply this knowledge, what you studied, what you gained from this chapter, and in your future endeavors. I hope you understand the whole chapter. And today's homework it is exercise number 8.3, question number 5, question number 8, question number 9, and question number 10. We will continue the next class with some other topic, some other chapter. Thank you very much once again.